Okay, our board is now in. On shorter standoffs than it was before, but it's perfectly adequate looking. It's starting to get a bit messy because long wires are now going in place. I have to put wires from here to the speaker terminals, all of the extra heater wiring to the board, and a lot of wires here that I have not connected yet, obviously, but it's starting to get messy. So I'm struggling now to just take my time to route each thing as cleanly as possible so we have a neat result at the end. In the format of an ST70, we always know that there's certain connections that go to the board. The board here doesn't have that many connections, right? However, we're now marrying this board not just to the chassis parts, but we're marrying it to the chassis parts through this bottom regulator board, right? So it gets a little confusing because, like, I know normally the certain wires that go straight from these parts onto the board now are going through this, into this, and then from this to this. Ran the wires from the board to sockets. Most of what remains has to be next connected to the power board. I'm kind of done with everything except for that. I declined to put any test points along the front panel. So because I have no test points on the front, and I kind of committed that I won't drill any new holes in the chassis, I looked around to figure out where I could put some test points. Before, I complained about some random turrets that were sticking up out of the board, quite tall, and I couldn't figure out why they were there. And there even 4 turrets right on these corners here. This spot here was connected to this capacitor trace junction. So what I did, I took my Dremel and I actually, on each corner, I Dremeled away the connection between the capacitor and these little corner solder pads. So each of these corner solder pads is actually now not connected to anything at all. So I ran a little black wire from there to the cathodes of the power tubes, which are floating 10 ohms above ground. That's the actual ground there on the left where I'm touching. And there's a 10 ohm resistor, precision metal film 1%, and they go to this junction of pins 1 and pin 8. So this wire, the black one, is going to those little corner tabs here. And these are now the test points. So basically, I'll be poking meter leads in each corner when I adjust those bias pots. Okay, next wiring session. I may have jumped ahead a little bit, but all I did really was put this board on, and all the loose wires from the last session were attached to various points along here. I kind of zoned out a little bit. When I read the manual, is that those wires should have been added and soldered from the top, reaching over the top and soldering on. I don't know, the fact that these have holes in the solder pads to me implies that it's to come up from below. So anyway, that's how I did it. Double check everything. There's no loose wires. I haven't missed anything. I have some exotic tubes hanging around, but they're kind of old and worn. Like I have 4 Muller EL34s and some Siemens. But when I look at them, they're all kind of looking like they're from different ages, and some are not looking so fresh, right? So for now, I just have a reasonably modern JJ set. So I went on my other set of Mark IIIs. If you look through my older videos, you'll see I did a restoration on a pair of Mark IIIs. I tried different driver tubes. Remember that the driver boards for those are the same company as this. And they were originally supposed to use 6DJ8 or 6922 driver tubes, but I read online that you could use 6CG7s, which are this taller version, right? And I had some hanging around, so I tried them and I actually preferred the sound. So I went online and I bought a bunch of old used 6CG7s, realizing that I'm a fan of them. And I've installed those. Now, one thing I did too, brushed on some concentrated deoxit onto all the pins, so that and put them in and out of the sockets a few times. So we kind of, with a little bit of friction, we kind of get a fresh contact surface. Because again, this amp and tube sockets could have been sitting idle for a very long time. Next thing, I've entered into the final testing phase. There's a step-by-step startup test routine so that the filament voltages are correct and lighting up all the tubes. The bias voltages are correct, and the bias pots, which are now relocated to the normal typical place for a stereo 70, those have the correct range of adjustment. And I got a very good range, because this says to look for minus 45 to minus 22, and I actually got minus 16 to 47. So I got a wider adjustment range than this was looking for, and that's nice, because if I ever use some, various tubes, KT66s or something like that, or 6L6s, those could use significantly different bias voltages to EL34s, and this sets of bias controls seem to have a good range, right? Okay, in this modification, you cannot use the tube rectifier. Now, I don't really think that tube rectifiers are a good idea in a hi-fi amp. The purists who want to yell at me, fine, go ahead, no problem. But also too, nowadays, the modern rectifier tubes that we have aren't so great. So even the tube purists are adding diodes in series with the tube rectifier to increase the reliability, or to even make them work, right? So I'm not into that. Anyway, the designer of this, of course, is not into tube rectifiers either. So what he did, among other things, is that the 5-volt transformer winding that normally powers and heats the tube rectifier is used here to power up part of the regulator circuit. Okay, so once you're using this board here, you can't have a tube rectifier unless, you know what, you could if you added another small transformer to give you 5 volts. So I've done well so far. I've hooked up everything correctly to the point that the first stage of checking, of doing testing, has passed. Nothing caught on fire, nothing smelling funny, no fuses blew, okay? So I'm gonna stop for now. I'm gonna reconnect these high voltage lines, which are under this red tape here, back onto the board. And we're gonna proceed with the high voltage set of tests. Okay, so I'm now further along the testing phase, and I've also removed the output tubes, right? And this is per the instructions here. And what I'm going to be doing here is checking voltages, ticking them off what's correct. And what this is going to do too is going to answer my earlier questions about how high do these voltages go in relation to my capacitor ratings. I expressed a worry before that because I expected to go over 500, I've kind of overbuilt the capacitor bank section with these two sets in series, right? If I find that at no point do they exceed 500, then I could actually get rid of these, which would increase my filter capacitance. And I could even rework it so these add to the capacitance, right? So let's see how high that voltage gets without the tubes installed. The point that the voltage goes the highest is in test mode, which is no tubes installed, therefore no load on the power supply. And also at the initial startup, where tubes have not heated up yet and drawn current, right? So in operation, it may be below 500, but it's when you start the amp up or you want to test something and you switch it on with no tubes, that's the danger zone. Okay, so here we go now. Surprisingly, on the first test, which is this C1A, we only have 474 volts, and that's no tubes installed and solid state rectifier. So it's a little lower than I thought it would be. I don't know if it ever passed 500 when I first hit the switch. I don't think so. I have no reason to believe so. Okay, so my concern right now is that all these voltages are on the low side. They say all these listed at 400 here plus or minus 15. So let's say the lowest should be 385. I'm getting 368. Now my line voltage from my wall is 117. This whole setup may be designed for 120. So I don't know where everything is on the low side. However, it says here, if the voltage Vref is incorrect, which we wonder if it is, when the circuit is operating correctly, there should be a voltage of 1.21 VDC across R25. And I'm measuring across R25 where that yellow clip is there. And I get 1.22. So I'm very much within spec as far as that part doing its job. And it implies that it is working correctly, though my voltages are a bit low. Well, I'm going further down the list and doing some testing on the driver board here, which is kind of going okay, except I think there's a typo in this manual. So here it says to measure ends of resistors 101 and 102 and gives the expected voltage range. But the problem is, this is 102 and 101 is down here, and then the same corresponding ones on the other side. The problem is I'm getting a wrong voltage here, but in the diagrams there's some test points specified here. TP2, TP1, 2, 3, 4, 5, and these are the 103 and 102 here are the plate resistors of the driver tubes, and those I think are what is meant to be tested. TP4 and TP5 there. So I think there is a typo saying 201 when it should be 203. That's very bold of me to say, but I believe that is correct, and what I am saying is corroborated by the diagram here. That's just one thing I point out if you ever find yourself in this very same situation. Okay, so I'm firing up for the first time. It's on now. It's warming up. And I'm following these procedures. There's some details here that are a little outdated because some of them are written for the original Dynaco 15.6 cathode resistors shared between each pair, which is not what I'm doing here. Remember, I have 10 ohm resistors on each tube on 4 test points. So I'm going to have to check those 4 test points and adjust these level pots and those blue bias pots to get 40 milliamps per tube. They did not mention in the manual to hook up the speakers or the resistor load, and I believe you're supposed to do biasing with that resistor load, so be warned, there's an omission there again. Okay, so I have this thing on a test point. I'm going to move this pot. The bias, the current is very low, about 1/10 of what it should be, and I'm turning this pot until we get up to about the 400 millivolt drop range. Right, so that's 395. This is still 385. All right, so I have a little juggling to do, but you get the idea. I don't need to get all of this exact while on camera. 40 on this side right now, 400 and 4100. 410 there. Right, so I'm going to move over to this other channel. So I'm going to roll that bias pot until we get up to 400. And by the way, I will keep going back and forth and double checking, triple checking, repeated checks, even while the amp is warming up too. Right, we're up to 400 there. When we shift over to this other side, it's, yeah, exact 408, 410, right? So it's kind of jumping back and forth. Now, let me just say, you never get a bias adjustment voltage to be exactly correct and stay that way. If you adjusted it to 400, you're going to come back 5 minutes later, it's going to be higher, it's going to be lower. You play some music, or you let the amp run for a little while, or you let it cool down, whatever, check it again. It's not going to be 400 anymore. It's always moving around. It's very dynamic. So bias adjustments, you just get a good average and check it back later, see if you have a good average again, and you go with that, right? All right, so that's how we are now. I'm going to let this burn for a while. I'm going to recheck these voltages. These may be even lower than when I just checked them because the tubes are in and it's biased up and it's pulling a load. So normally in a tube amp without a regulated power supply, these would dip heavily between whether the tubes are installed or not. Okay, so let's actually check that out of interest. Will these voltages be the same with the tubes installed? Let's have a look. Well, folks, to be honest, I think I'm going to put a pause on things. I'm reviewing these voltages here, and they are pretty close to the initial measurements. However, I think we're just too far off. This PREG, Preg and Sreg over here, is saying 400 volts plus or minus 15. I'm getting a lot less than that. I'm getting 368, and that's too low. So those are the regulated voltages. Okay, now the unregulated voltages, the last one that before it goes to the regulator is this 440, which is reasonable, right? So I think our regulator setup is losing too much voltage, 70 volts. So I think something's wrong with the regulator. Okay, I'm going to look into that. The other thing I'm going to check too, which is a little easier, check if the main initial rectifier diodes are okay, right? Because if one of those is off, we could have that drop in voltage. All right, but still, I've hooked it up. I've put a 1K signal into both channels, and we have very nice looking clean waves. Those look very nice. So let me play with this, and let's see if we get something of a power measurement. We have a little channel imbalance here. Yeah, let me test maximum power and kind of see what the results are in consideration of the low plate voltage. I have an old smartphone there working as a function generator. I'm sending a 1K sine wave to this preamp, which is going to act as our volume control and strengthen the signal a bit. And we're going into our oscilloscope here. So when I crank up, I am getting on one channel, well, running simultaneously, but I'm measuring one channel here. I'm starting to distort the top of the waveform at about, look at that, 16.5 volts. The volume knob is in steps, so it's kind of hard to get. Yeah, it's flattening off. Let's get it bigger. It's kind of flattening off. Wow, look at that period. Look at the period RMS figure, right? And we're starting to flatten off just about 17. We're still clean. If we go over 17, we start to distort. All right. So that's pretty good. All right, let's do the math on that. Well, folks, this is a kind of big surprise. I mean, all right, I don't have fancy test equipment here. I don't have distortion analyzers and sweeps and so on, but we're just looking at the wave on the oscilloscope here. So I'm checking the other channel here. We're going again. And this is starting to clip. If you watch the period RMS, this is the other channel from before. It's just at around 17 volts. It's clean, right? Well, even, you see what I'm saying? You see what's jumping around there? But that's around where it's visually clean. Beyond that, it clips on top, square wave, and then it also gets crossover distortion, right? So it clips pretty hard. But it's going all the way to 17. Now look at the math. This is fantastic. This is a low voltage test results because, again, I'm not happy with the plate voltage. It's too low. 17 by 17 RMS, just 289, divided by 8, which is our test load, 8 ohms, 36 watts RMS. That's right at the Dynaco 35 watt per channel standard. And in fact, some people would say that they don't make it all the way up to 35 watts per channel. But here we could see a pretty clean wave right up there with minus any distortion measurements from equipment that I don't have. So wow, that's pretty great. So I just wrote an email to the designer of these boards, who has been very kind in giving me paperwork so far. And I gave him the measurements that are bothering me, and I asked what his feedback on that might be. Okay, but I have to tell you, according to this, it should be working just fine. Okay, well, good news. I emailed the design of these boards with the pertinent information about the voltages that were a little bit in question. And he emailed me back within a day and said that is correct. That the voltages that I'm reading are in the correct relation to each other and indicate that things are working well. So again, I'm a little skeptical because the overall operating voltage seems low to me, 370 volts, right? I went digging around a bit online and I found someone else mention some similar concern about the same modification boards. And they said that theirs was 380 volts, but they had an even higher starting voltage. My starting voltage before the regulator was 477, and theirs was over 500. So I figured, well, in relative terms, mine's better off. He said it seems to be working properly. Okay, so that's the best I can do. However, I'm still gonna do a few little things. I'm gonna disconnect the high voltage leads that lead to this board here, the red ones that come straight out to the transformer, and we're gonna measure those voltages, because if those voltages happen to be on the low side, whether it's from the line voltage or it's just that transformer, what is the voltage out of the red winding with nothing else connected, no load on it? We're going to find out. You know what? These same transistors, these voltage regulators here, again, they're 30 years old or more, and I think I'm going to go ahead and replace them, right? Because who knows, they could be a little worn or something and have the voltage down a little bit, and it's no big expense to replace those. Another thing I noted, and I didn't like it, this part here, this heatsink where I'm touching, when the amp is running, that carries over 400 volts on it. You could get zapped whap with 400 volts just touching this thing, right? So I realized that this is an uninsulated heatsink. Okay, so I have ordered little fittings to remount it insulated. I thought that was just too dangerous, especially have to come down here to do bias adjustments. And then also too, I might have another crack at this front faceplate. Okay, so the last time I tried to engrave into this aluminum sandwich board, it was a complete fail. This aluminum seems to be pretty hard. When it started up here, the fine little bit that I used broke pretty early on. But not only that, the upper layer of aluminum, which you see here, didn't even stick to the black plastic below in the lettering. So even if this cut properly, it was still a bit of a flop because the text wouldn't have come out good, right? A regular hardware store 1/8 aluminum sheet sitting here. Instead of using a fine flat bottom bit, I'm now using a 90-degree V bit. And then at the end of it, you're going to use a big, huge, full-size 1/4-inch bit to cut the outer perimeter of it, right? Okay, so again, we see the drawing, and we go into what we call the tool paths, and we pick out each line in each text, and we say what we want to do with it. Right, so I'm going to change all of these to V-tip type engravings, and that will solve our problem. Change to a V-type bit, and we look at the simulation. And you have to admit, on simulation, it looks pretty good, right? So we hope that the real thing could look as good as the simulation, right? That's all we could ever hope for. Okay, now there's another version I can do called an advanced V-curve, and it yields this sort of double line version. which also looks cool as well, right? So we actually have options, two different versions. We could go deep into each letter as one stroke, or it could kind of go around the inside of the letters, not as deep, in two strokes, yielding two different styles, right? Let me tell you, if you're not into CNC, you'll spend 100 times more tweaking software and adjusting things than actually carving on the table. Okay, that's how it goes. So we're going to start here. There's a lot of aluminum dust debris to clean off. I think that's as best as we're going to get. Okay, so let's move on to the next phase, which is to actually cut the shape and the holes for the RCA jacks in the middle there. So I get to change bits, reset the machine to make sure I don't lose any XY coordinates. That's the most important thing. And then we run a whole new file with the same drawing, but we're going to cut different parts with different bit, right? Okay, so we've shut down there, and I think this is a great success because I haven't gone all the way through because I didn't want to dig down through the metal into the MDF below, even though you could see I've made that mistake here before. Cool, so let's work on this. Well, how you like that? How do you like that? I just cut it on the bandsaw away from the waist, and I went over to the belt sander and just trimmed off the very little edges, and I kind of run this face on the edge of my belt sander, which give it this textured brushed finish. So like I'd switch the belt sander on, and I'm just running it on the grit like that a bunch of times, and boy does that look nice. That looks so pro. I hope the aluminum stays that way. You know, sometimes it gets kind of oxidized. So the initial plan was to put black paint in the into the text to show up the text and contrast, but I don't know, I think it looks good just as it is. Damn, that's nice. Well, here we have it. I think this came out even nicer than if the first aluminum attempt had gone well. Really cool little machining marks. That just looks gorgeous. So our black one, which was the substitute, turned out a bit of a waste, but I think through persistence, we end up with the best results. Okay, so we have our faceplate in place. It's looking good. I have stuck it a few little drops here and there on the back of RTV silicone and some O-rings and heat shrink and so on to isolate the RCA connectors from the metal. Kind of noticed that the output voltage from this transformer and our resulting plate voltage and screen voltage is on the low side, definitely. Even though the modifier says it's okay. Okay. Right, so what I want to do, I just hooked up the meter very quickly. I just want to test what's the AC voltage coming out of this transformer when nothing is connected. The other thing is this. Early on in the project, I put in this thermistor, which is supposed to give some resistance to the primary circuit before you even hit the transformer. As it heats up, it goes low resistance and it's then out of the circuit and everything is operating as it should. However, I never really tested. Is this in fact going low resistance? Or is it staying at a certain resistance and lowering our secondary voltages? I want to see what the voltage is, as I just mentioned, and then I'm going to bypass that thermistor and see what the voltage is. Okay, I just switched it on and turned it back off, but in switching it on, I did notice a slow ramp up voltage, like it kind of hung out at 500 volts for a second, and then it ramps up, and that's exactly what the thermistor is doing. As it heats up, it's lowering its resistance, and this is increasing. So we want 700, and I think we can agree that we are getting 700. Okay, so as far as specs go, this transformer is doing what it is supposed to be doing. Okay, look, we're up to 710. Now this is no load. The output tubes are not in, so there's no heater current from the power tubes, and there's no current from the actual audio circuit. So this is a no load, almost a no load condition, because the preamp tubes are plugged in. And look, we're actually up to we're probably going to hit 715. Here we go. So our transformer is at spec. Okay, let's just bypass that thermistor and see if our maximum goes up a little bit. You see, it keeps going up, and while the amp is running and getting hot with the load, it should be heating up even more and lowering the resistance even more. So I'm scrutinizing. So I'm looking for a problem at the power transformer and the thermistor, but I'm not getting a problem with either. Look at that, it's practically 720. Okay, so I've just bypassed that with our alligator clip. I switch on again, and we should jump right back up to 7 something quickly. Wow, 7. Oh, that's what's going on. That is what's going on. You see, we did find a problem here, folks. That went immediately to 744, which is roughly 25 volts higher than what I just showed you. Okay, so yes, our thermistor is giving a problem. We're losing 25 volts. Now, again, this is a no load condition, but that 25 volts, even if let's say it's 20 under load condition, reapply to our regulated voltage, which is now 370. If I could get back around 20 volts onto that 370 would be wonderful. All right, so let's see them going higher. Okay, hitting 750. Okay, so here we're gonna bypass this thermistor, put the load back on, and let's see if we could get that plate voltage up where it clearly should be. Okay, so I've reconnected the high voltage winding. I don't have the tubes in because I want to test the regulated voltage. And from what I wrote down here before, when I got the 370, 368, that should be the same regardless of whether the tubes are installed or not, because it's regulated, right? So now I'm going to flick on the amp, and then we're going to test that regulated voltage. Hopefully it's gone higher than the 370. And whatever higher voltage it may be, that will be our new permanent voltage. Also, to remember, I was saying that the voltage that we tested never exceeded 500 volts. Therefore, our capacitors were never in danger, right, at 500 volt rating. But now who knows, it may cross 500. So I've left in place the safer version of the capacitor filter setup, which is at 800 volt rating. All right, so let's flick on and just see what happens when I poke the tester onto the VREF here. All right, so VREF, and we're looking for, there we go. Oh no, it's this here. This is here, 370. And what else can we check? All right, we can check C1A. This should be higher than it was before. Yep, you see it's crossed 500. That was 477 previously. Right, so we have crossed 500 on the filters. This one is after the choke. Same thing. This is the actual voltage that feeds all of the others after the choke. Look at how cool this thing looks compared to when we first got it. We got the matched capacitors, we got the deck here sitting lower than before, and this awesome looking new faceplate. I mean, geez, in person, it really comes across nicely. Right, got the brush finish, nice deep carve. It kind of throws a good shadow on its own text. So the lettering is very apparent, even though there's no paint in there. I went online and I looked up the the parts using these regulators. And this uses a 317, LM317, which seems to be a very common one. And on that, the ratio of these two resistors here determines what voltage may come out here, right? Very roughly speaking. I don't want to get too detailed. But basically, if I increase this resistor value, we could get a little more output voltage here. This is presently 100K resistor, that little blue one there, right? And if I think that if we bump this up to somewhere between 105 or 110, 5 to 10% increase, we could end up with 400 volts here, a little more from some calculations that I did, right? So I pulled out some resistors here. I have a 4.7K, I have a 6.8K, I have a 10K. And I'm going to try putting these in series with the 100 that's there. And let's see if we don't get just over 400. So we have some results now. I tacked on the 10K resistor, so it's 110K in the regulator circuit where it was 100 before. And the last time we measured here was about 505. And we're back there again. Thermistor bypassed, right? And we're going to go after the regulator. That's what they call VREF. And look, we're up at 425, which is great. I mean, that's, again, fully regulated and it's going to give more power, right? The tubes are going to run cleaner. So I think I made a good adjustment there. Also, too, when we look at this test chart for when we first do this setup, it said that voltage should be 400 plus or minus 15 volts would be normal. So I was below the accepted tolerance, and now we're a little bit above it. But we can back off and put this 6.8K resistor. I'll probably get it down to about 415 or so. So I've changed from a 10K resistor down to a 6.8K in series with the initial 100K. And let's test and see what that shows. I have now swapped to an 8.2K resistor. And let's fire up and see what we get. I have a few other values on hand. Okay, so we go straight off the rectifier. We have over 500 again. And what do we have on the regulated voltage? Oh boy, 400 on the dot. That's what it's supposed to be. 400 on the nose. So yeah, I guess it's supposed to stick with that. The other voltages for the screens and plates are right there with it. Design center value is wow. Cool. So our resistor that was 100K works better when it's 108.2K. Okay, now having achieved that perfect design center 400 volt, the backup test is down here. And it says if the voltage is correct, blah, 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 blah. When the circuit is operating correctly, there should be a voltage of 1.21 VDC. And I measured previously 1.22. And I just did our adjustment there and measured it again and got it again at 1.22 VDC. So this is perfectly fine with the resistor adjustment that I just made, right? So we're all clear. Right, so again, if I wanted to adjust the bias with these controls down there, or if I wanted to just swap preamp tubes, right behind them is this heatsink, and check it out. There is the full voltage of the rectifier is present on this heatsink. Okay, now that's not cool. And then this is the regulated voltage right next to it on the chip, and they're almost bumping into and touching each other. And that's dead on 400, right? So it's kind of amazing. All of a sudden, things have taken on some very, very even numbers around here. Okay, I am back in action because I finally received the parts I've been waiting on, just the last few things. Now, those parts are the regulator chips. I replaced 4 regulator chips, 2 on this bottom board and 2 on this top board. just for the purpose of seeing if any regulator chip breakdown was giving me that low 370 volts. As I mentioned before, I've altered the resistance here to bring the voltage back up to 400, exactly 400. But let's now trying to see if those old chips were responsible for the 370. Now, while shopping for parts, I had a little change of heart on one or two things. This big filter capacitor here is not what was there before. So this is a huge 350 microfarad capacitor. The thing about it, why I bought it, is because it's rated at 560 volts, which means I can use this capacitor for the main after the choke. It's a huge capacitance, and I don't have to put two of them in series, okay? The ones before these here, I have now arranged in series with each other, and these will handle the highest voltage after the rectifier and before the choke, right? So these strung together will be 110 microfarad at 800 volts. And after the choke, we have 350 microfarad at 560 volts, which should handle anything this amp can throw at it. The last two sections, 100 and 100, are the same. So that's the only filtering alteration I made with this new batch of parts. Now I'm going to go through this startup checklist again, and all these big relevant voltages here, I'm just going to double check with the new regulators in place. Okay, so first on the table we're checking C1A, which should be 450 to 550, which is the voltage right after the rectifier. And we are getting, look at that, we are getting almost 500 on the nose. How is that for design center value? In earlier tests we had gotten 477, right? But I think that was with the thermistor in place, so we've removed the thermistor. Okay, next we have C1B, which is after the choke, and that's also attached to the largest filter, and we get just about the same thing, right? Cool, we're doing good so far. Both are on design center. So I've gone down the list, and all of them are pretty much the same voltage here. You see, these are all supposed to be about the same, and they are about the same, about 4647. Now that concludes basic testing. So now I get to put the power tubes in and the preamp tubes and go through the biasing procedure. I'd mentioned before that I had changed this electrolytic from 10 microfarads to 22 just because I could, but I was corrected by Mr. Curcio, who said to stay at this, and I read a few other remarks online that this should stay at the original prescribed value of 10, so that's back to 10. I have redone the heat sinks with insulators so that those aluminum pieces you see there are not live anymore. Okay, so this is the resistor set that I had adjusted to get back up to 400 volts from 370. We've seen that before, but I can't leave this hanging around like that, so I'll just neaten up that soldering. I also cut two little slots at the top of these potentiometers for the bias level adjustment, so they can be turned with a screw. Can you imagine, before I didn't have these slots, so I was sticking my hand in the back here to adjust bias, not realizing there was 500 volts and 400 volts right here. Okay, such was my naivete. But now these are isolated and there's a screw slot there, I'm much safer. Okay, I've adjusted each corner just a hair under 40 milliamps each. Okay, so we've done all the hardware work. The only thing between this and listening is let's do a little power test. Let's run the oscilloscope on this and just look to see how much power we get where there's visual clipping of the sine waves. I don't have distortion analyzers and bandwidth checkers and so on. So let's do that next. I'm just checking a few voltages here and a quick recap. When we went through this list earlier, this is with no power tubes installed, and we had 500 here at the top. Okay, but with tubes installed and biased up and everything, this voltage, which was 500, dropped down to 450. I'm getting almost exactly 450. Now that 450 volts is a little important because when I spoke to the designer of this, Mr. Curcio, he told me not to try and raise that 400 volts plate voltage up too high, because you need a certain difference between the input and output of the regulators to make them work. If the input to the regulator falls below a certain threshold, I can't remember what the voltage is right now, but if you close the gap between the input and output voltages too much, it won't work, right? So that is another reason why I got rid of that thermistor. With the thermistor in place, that 450 volts we might have seen there might have been lowered, might have been 430, 425. And that would have closed the gap between input and output of the regulator too much. And we couldn't have brought the regulator output up just above 400. We would have had to have left it down below 400. So it's just, I know I'm kind of going back and forth on that information, but that's, again, just something to think about. Okay, so we're all hooked up. I have a little, just a smartphone sending in a sine wave. I don't have a fancy signal generator. And we hooked up to test loads and oscilloscope, right? So I have a preamp here that I use to drive that signal in, because straight from the signal generator is not enough. And we have very good channel balance here right now. Okay. And we're going to simply crank up until we start to see clipping at the top. That's all we can do here. Around these parts. Me ain't got no distortion analyzer. Okay, we're cranking up pretty good. Topping out, you can hear the transformers squealing. Right there, boom. All of a sudden we get crossover distortion and square wave clipping at the same instance, right? So I'm leaving it right there. That is our wave to test. Okay, I'm not getting the most staggering wattage output figures here, but at a 400 volt plate voltage, that's what we can expect, right? So I'm going to crank up here, and we'll observe the channel 1 and channel 2 period RMS. And I can't say that I'm getting beyond about 15 before it's obviously clipping at the top and distorting, crossover distortion. What is that saying right there? About 15 and a half. Let's say 15 and a half. The thing is, if I do one channel at a time, I will get a little more. So if you observe the yellow channel there, one channel at a time, I will get, well, 15 and a half, 16, about 16 and a half, right? If I do one at a time. So, okay, so from those RMS voltages here, running simultaneously, we're getting 15 and a half. We square that, we get 240 and a quarter, and we divide that by the figure of the resistive load, and that is 8 ohms. So we end up with 30 watts RMS, nice and clean, running simultaneously. That's pretty good. I don't really, at this moment, have a comparison to other Dynacos with this set of mods in it. In fact, there's very few on YouTube, you may notice. So single is just a little higher, 16 and a half, we get 272 and a quarter. Divided by the same 8 ohms, that's 34.03, which is closer to the desired 35 watts per channel. So those in the know instantly know that the difference between these two figures is likely the power supply, high voltage winding just giving up, on current supply, basically. Even though we have a regulated boards here to mitigate that, there is still probably some, I don't know, there's some lapse when both are cranked at the same time, right? So anyway, this is not bad, because again, we're not shooting for a big pile of power here. We're shooting for clarity. Okay. Here's a quick look at the web page for this mod. Claims 30 watts a channel, not 35 or anything higher. Plus all these other specs that I have no equipment to prove, right? But look at this, some very wide bandwidth, 0.05%. Wow. These are the 6 CJ7s, I also have a set in here of the 6922s, and I dug around in the original Stereo 70 manual, of all places, the actual RTFM, and it said that the original Stereo 70's output for preamp connections, right, caters for heater voltage and current up to 1 amp. So the original design is catering for, let's do that math. Right, so these are the various heater setups here. The original one is 2 AL34s at 71.99 plus 1 amp extra for preamp use. We had 4.45 amps. So that's factory recommended for long-term, regular, reliable use. Okay? Our option here, 6CG70, 2 EL34s, no tube rectifier, by the way, which adds heat to the transformer. And then 0.6 amps each, giving us 4.2 amps. So this configuration we're using right now is less than the nice long-term factory recommended maximum. And the 60G 6922 option, these have a little odd figures, 0.365. So that 1.5, 1.5, that is 3.7. So obviously this is the coolest way to run the amp, and you'll be well under the sort of factory recommended maximum. Yeah, so I'm going to be choosing between these two. This running amp, not really cool. They never really run cool because there's a lot of strain on that one power transformer. But you know, if I did find that the amp was just kind of running too hot and worrying me, I would switch to this option here. But ultimately, I really want to use the one that sounds best. Okay, so what I'm doing right now is swapping back and forth between the old and new regulator parts, but I'm not really getting anywhere. What I'm seeing, so when I crank up to clipping, the edge of clipping, I'm getting this voltage sag. It's going from about 365. So when I turn down, let's say 0 signal, that same voltage is 395. So the problem is I'm backtracking all the way to the rectifier. The initial voltage that's coming through this transformer out of the rectifier is dipping down a lot when cranking up. So let's say this is before any of the circuitry. This is straight off the rectifier. And if we crank up to the edge of clipping, which you can see in here, that voltage is going all the way down to 415. Now at this point, the regulator is not really going to work because I mentioned before that, look at that, that is the voltage feeding the regulator. So if it dips this low, the regulator can't do its job because it has to maintain a certain threshold, right? So what do I do? How do I prevent that sag? How do I change? Oh boy, you see this situation, I don't really have a way to prevent that sag. That's straight from the transformer. So that is basically what you're seeing here is the shortcoming of the power supply of a Stereo 70, right? It's just so much you can do, you know. All right, so I'm gonna keep tweaking and see what I could figure out. I'm even monitoring the heater voltage here, and you can see it's kind of going a little bit above that. Yeah, it's kind of moving around just below 6.3. If I crank up again to clipping, just underneath clipping, even the heater voltage is sagging. Let's back it off. See, it's going right up above 6.8. So even the high voltage winding is saturating such the voltage is dropping on all of them. This is strange. Anyway, it illustrates the shortcoming of this power supply. Okay, to summarize and finalize a bit, it's the power transformer is the limiting component here. Let's say I test one channel at a time, I will get up over 17, I'd say about 17.5 volts right at the point of clipping, which is as much as 38 watts, but that's one channel running. If I switch over to the other channel, the blue one, same thing again. We'll pass 17 at the point of clipping. 17 would be 36 watts, right? So, but once I run both together, they both stop at around 15 or a little higher than 15. And that is when the power transformer voltage starts to sag right around there, and we limit to about 30 watts per channel. Also too, when I crank on one channel alone, there's no sag at all from any of the power supply voltages. It's when I do two channel, it's when the sag is in place. So again, power transformer limited. The thing to note too is that this sag of the voltage is only happening when it goes into clipping, right? It's not really saggy in normal operation. Well folks, that's about it. I think I can wrap up commentary on this project. I'm very happy with how this amp sounds. It is crystal clear, clean. When I'm listening to anything, I mean, the clarity of things like vocals and drum cymbals, the drums are starring in everything that I'm listening to. You know, it feels like they're in the room. And even vocals, when someone yells into the microphone, when the band really leans into a chorus, you actually hear everything get louder. The dynamics are amazing, right? Drums are particularly nice. Right, so right now I've been using them into my KEF 104.2s. Probably not the best match in the world because the KEFs are power hungry and I find they're a little bit short on bass. But I've been mixing it up with different speakers and overall really, really happy. My last comment, I did try the 6922s versus the 6CG7 as we've been discussing before regarding heater current and so on. I prefer the 6CG7s. The 6922s sounded a little louder and harsher. Things like drum cymbals and stuff, I would start to hear almost a little bit of an overdrive and harshness. And I read that the 6922s actually do have a higher gain level than the 6CG7s. And that seems to explain it. If I swap these right now into this, the volume would go up, but then some harshness as well. I really prefer the way the 6CG7s sound overall. So that's my conclusion. I think this is a really nice project. It came out great. And the quality of this board is really very good. I didn't have any problems with anything, right? In fact, even with these 6CG7s, after all the worry, I don't even think that the power transformer runs that hot. Look, I'm leaving my hand on the core and on the top, and this has been on all day long. This is it's like I'm recording now. It's 3 p.m. in the afternoon. It's probably been on since 10 a.m. Right? So that goes to show you can function with this heater current just fine, right? Okay, so I'm going to sign off. I hope you enjoyed the little two-part series. For those of you who cringe at Dynaco mods and you want to leave everything stock, sorry to have bothered you. But yeah, this is a really nice configuration.